Hello, my name is Christian Nomine. I'm a strategic product manager for visualization and data analytics at Mitsubishi Electric Europe. I would like to give you a live demonstration of a typical example that we can solve with our data analytics software called MailSoft MyLab. MyLab is a web-based software, so once we started it, MyLab will guide you with an intelligent AI-driven configurator through all the steps required for the project. So that is, we need to create a data set, first of all. We need to create an AI based on that data set. And finally, we need to create a task, which is an online analytic way, which is very much similar to your understanding of a task running in a PLC, for example. So when we start with that, and the first step is creating a data set, we need to make sure that we covered all required process parameters and ambient parameters from the process, which are crucial according to the process experts to give value into a data analytic model. And in this example for the noodle factory, we have a demo data set consisting of 7,000 records. And that data set can obviously be viewed in a table. And one of the most important things is that the last column, the noodle kneading time, is what we have logged and recorded over time from an experienced operator, how based on these process parameters for the noodle making process, he did set the perfect noodle kneading time. So you can look at this data. MyLab is offering some great graphical tools for that. So first of all, you see a lot of statistical data, but we can drill deeper. We can select the noodle kneading time and just create a line chart, for example. And we will understand that these 7,000 data sets are consisting of little variations in the noodle kneading time between 12 and 16 minutes. So we have confirmed our data set. It's good, it's valid, and we can actually do the next step. And once completed, MyLab will propose to create an AI. So MyLab offers 4 completely auto machine learning based automatic algorithms. But for those who already have an experience in data science and they know what to do with all these algorithms, supervised learning algorithms, unsupervised learning algorithms, they can completely start a manual project. But this is not us. This is not us for this demo. What we would like to do is to create a completely guided system based on our noodle kneading data set. And MyLab will propose the 4 typical use cases now that are implemented almost completely automatic. So there is to detect errors. For example, this is a typical predictive maintenance task, wearing out of parts, for example. There is a quality index for supervising the machine when it produces a part. What is the quality of this based on data? But what we would like to do is the third point. We would like to learn from skilled operators and to transfer his knowledge into an AI. And in this little example, and you will see this in the next step, the knowledge inside the data set sits in his chosen set points for the noodle kneading time. And this is what we would like to predict with that algorithm. So we will select this noodle kneading time. And then the AI is actually almost ready to go. All we need to set is the different level of complexity of the model that we would like to learn. We would like to start with the easiest one, which will result in the highest speed for this demo, as well as selecting only 2 algorithms. Also MailLab, from the toolbox that it has with many different algorithms, it will pick the ones which are best suited for that specific application. So once we start the learning, you will see that the whole pre-processing will now start automatically, and actually it's already done. We will optimize the model, and we will finally, once this is done, and you see it's completed in 10 seconds, we will be presented with a so-called precision score. So this is a percentage between 0 and 100, which indicates the precision of the algorithm. So MailLab is also clearly saying to the unexperienced user that this is a good score, but even more helpful, from all the process parameters that we collected in the dataset, MailLab shows a graph which of those process parameters has contributed to finding this precision and this model most. So in that case, it's flour. When we are happy with that model, MailLab will present a kind of block diagram where you see in pink all the pre-processing blocks that MailLab ML has put together, the 2 parallel algorithms that MailLab has tested, and something which is called an ensemble learning block. So we are actually adding another layer of AI by trying to analyze each individual model and trying to make it even better, and only the best result will then be the output and the prediction of our AI. So you will get a feedback here, for example, with a score. Yeah, and of course, this is just a demo and very quick, but you would now typically go back to the process engineer and ask him, well, if we run this model, is it good enough with a precision of 90 or, for example, 93% to make it worth? Is it worth actually running it online and creating a task? In this quick example, it definitely is. So we created a task, and you see that the task is something I can stop and start, just like a PLC. And a task can also be configured. And the way it can be configured is we are now creating the closed loop flow of information from an input flow. And you see, for example, there is a variety of streams available. So it could be text files, simple CSV files that you, for example, export from your SCADA system. It could be a direct Mitsubishi driver that I'm using right now, an OPC-UA server connection, or even a database connection. Those are the typical types. So we are defining our physical channel for the live data. We are then feeding this live data into our AI, and we will calculate an output with a prediction of that model, and in that case, the predicted noodle kneading time. So again, when we run this, MailLab also comes with a built-in, very nice and advanced looking graphical engine, because once it's running, just give me a second here, we are then able to go into the monitoring mode, where another tab will be opened. And now what you can see is that each second we will retrieve data from the incoming process. This is a kind of diagnostic page here. You will see that calculating the model will take this amount of time, and writing the output back to the PLC in that case will take that amount of time. But most important is, of course, the prediction. You see all the process parameters coming in here continuously, and MailLab is now based on the process parameters, the perfectly predicted noodle kneading time with a dedicated precision that the model allows you. In that case, it's 90 or 93%. Thank you very much.